Hi, I'm Bloatfish. In this video, I will be going over the various circuits and relevant theories found within the Super Smelter featured in Mumbo Jumbo's Hermitcraft Season 6 industrial area. Small disclaimer, this is Mumbo's design and not mine, and therefore I have linked the original videos below. For the building tutorial, please check the video link below as well. This video is mine though. For some basic information, this system is composed of a tall side and a long side, where the redstone is concentrated within the tall side of the system, while the long side is more variable because you can change the number of furnaces and hence the length of the system. As for the parts of the system I will be analyzing, this will include the fuel water stream at the back in yellow, the minecart ejector with storage in green, the minecart item loading circuit in red, and the output to Autodropper water stream in blue behind the system over here. Then, some more information on numbers, fuel types, and an optional circuit for a fix. To start really simply, how does this work? In front of me, I have a really typical section of this system. You can see it's of the long side of the section, and just for easier building, it is 6 in depth and 7 high, as shown. Before you start using the system, you have to load it with fuel, and so, in this water stream, you just input items into it. It flows through this water stream, along this iron bar and down into the hopper, which goes into the back of the furnace. And then, when you use the system, you place items into the double chest, and then eject the minecart, load it up with items, and then it flows through, goes along this powered rail, which is powered by this redstone block above, which then sends one item into this hopper into the furnace, and then, because there's fuel already inside it, it gets smelted, and goes down into this Autodropper, which because of this blue circuit over here, gets ejected into this water stream, and then gets sent to the output chest. The first section of the smelter is the fuel water stream. It is located behind the system, and this is obviously where the fuel flows into the system. Now if we just sort of simulate that, we grab some fuel and then we insert it into the system by throwing it against this double chest perpendicularly. You can see the items will get picked up by this hopper over here. So what happens is that the main concept here is the item's hitbox. If we look at the hitbox of the double chest, you can see it's just shy of a full block, because there's like this pixel-wide gap in between. Which means is if we throw the item into here, the item's hitbox will travel slightly over to the next box. And so when the item travels through this entire water stream, it will travel between these two blocks, because it's like going over. And then because there's a hopper in the way, the item gets picked up by the hopper and then goes into the furnace, just like that. In comparison, the double chest has been replaced with full blocks. And so, if we simulate, again, inserting the items into the system, and then turning on the hitboxes, like that, you can see that the edge of the item's hitbox doesn't actually go over, it's aligned with this full block, and so the hopper doesn't pick up the item. However, again, in comparison, if we just replace this with the block so it doesn't get picked up, we throw items against the double chest. The item's hitbox, although not too obvious, is actually over this line, to show the boundary between blocks. And so if we replace this with a hopper, the items will get picked up and to show that the items were actually over the boundary. A few more comments for this section of the smelter. The first is that you definitely need to extend this water stream and make sure the item enters by going past this ice block like this. You may consider using item elevators or soul sand, but you definitely do not drop the item from above, like this. Because, the item just sits there and might despawn and is a waste of fuel. The second thing is the reason why the item has to travel between these two blocks. And I'm pretty sure it's because items might get stuck within a full hopper. If we just simulate a full hopper, maybe like a full hopper of fuel, and then throw an item into here, you can see the item has slightly sunk into the hopper and is possibly stuck. So again, a waste of fuel. And finally, regarding this iron bar. The point of this iron bar is to keep the water from flowing over the hoppers, but I think you can most likely replace this with fences, although I don't really recommend doing so, because iron bars are cheap enough. One hopper is 5 iron ingots, this is simply 6 iron ingots, and well, it has a narrow hitbox compared to fences. So I do recommend using iron bars more. The second system is the Minecart storage and ejecting system, which is in green. This system activates either with a button pressed behind here, or when an existing minecart is sent out of the item loading circuit in red, so which then sends a pulse through the circuit to call a new minecart to get loaded up with items. Just to show that really quickly, you can see that the minecart will phase through the block and then get sent out. However, before I start introducing how this works, I need to introduce a few concepts. The first concept is rising edge and falling edge. If you look at this circuit really quickly, for rising edge is defined by if I turn something on, it's the sequence that follows. So if I turn this lever on, the sequence is that this redstone dust will turn on and all subsequent components. Now falling edge is just the opposite. If you turn something off, then the sequence that also follows. So now this lever is technically on because like this redstone dust is on. But if I turn this off, the redstone torch will turn on, which is again the sequence that follows. Secondly, I also have to introduce a few component delays. So redstone dust has no delay whatsoever. Redstone torches have a 1-tick delay when you turn on or off. And then finally, pistons will have a 1-tick delay when you turn on and no delay when you turn off, meaning it will retract instantly. To explain the rising and falling edge sequence of the circuit, I'll be using this variation over here with a lever, which this is just a copy of this over here without the lever. Anyways, so initially, this redstone torch is powering this sticky piston, which is extended. If I turn on this lever, or the rising edge, then this redstone dust will turn on, which will also power this piston, but then this redstone torch will turn on after 1 tick of delay. And because, well, this piston is already powered, nothing will actually happen like that. And then you can see this is off. However, on the flip side, on the falling edge, when I turn this lever off, this redstone dust will turn off immediately, and then this redstone torch will turn on after 1 tick of delay. However, because this piston has a 0-tick delay when it is deactivated, it will turn off immediately, then this will turn off immediately, and then 1 tick of delay after this redstone torch turns on, which repowers the piston, and therefore the piston will just have a really short just on-off like that. This amount of time is just enough time for the minecart to clip through. Again, a few more comments for the system. The first being this rail intersection. How does the hopper minecart go from this down here up to here? This is my interpretation. So, when the hopper minecart is ejected, it goes down and snaps to this powered rail. It then goes up to this slope, and then when it's on the slope, the hitbox of the hopper minecart is able to intersect the detector rail, and that's how it just jumps from here to here. I think that's what happens. Anyways, the second thing, the more important thing, is this button behind here, the activating device. This doesn't actually have to be an oak button, it could be a stone button or even a lever, because it doesn't really matter how long it stays on for, or the pulse length, like this, or it doesn't really matter, because what's important is when it switches off, because that's when the piston will activate and deactivate, something like that. So you can see that all three of these work. The other requirement is that you just can't have a pulse length smaller than 1 because, well, this redstone torch doesn't react to pulse lengths that short. For example, I put an observer here, pulse length of 1, nothing happens. Yeah. I recommend using buttons. The next system is the Minecart item loading circuit. This system is located between the Minecart ejector and the furnaces. I would describe this circuit as the brain of the system. That's why it's in red. But what I mean is, this hopper determines the number of items that will be loaded into the minecart. I'll explain the wider significance of this circuit later on, but first, how does this actually work? The first thing that happens is you call a new minecart from the system, so it ejects a new minecart, goes along the rail, through the slope, and then stops above this detector rail, which technically is stopped by this fence over here. So, in this position, the hopper minecart is able to load up items from the double chest above, and because it's above the detector rail, it sends an output to the comparator over here, to the back of this comparator. Next, I mentioned that this hopper determines the number of items that will be loaded into the minecart. You can see that this comparator detects the number of items in this hopper, and then sends a signal to the side of this comparator. And as you probably guessed, this comparator is the main component of this entire circuit, as it compares the signal strengths from the side and the back, which basically means it compares the number of items in this hopper minecart and the number of items in this item hopper. When the number of items in this hopper minecart slowly exceed the number of items in the hopper, then this comparator will send a signal to the redstone torch, which deactivates it, and then retracts this piston to allow the hopper minecart to go through. And then, again, because there isn't any more hopper minecarts, this redstone torch will reactivate and then extend the piston. It then sends a new pulse to this ejecting circuit to call a new minecart and then repeat the entire process again. The final system is the output Waterstream Autodropper. When the furnaces finish smelting their items, they will drop their items down into a hopper below, which will then funnel their items into a centralized hopper down into a dropper. And then, due to the automatic dropper circuit behind the dropper will spit out the items one by one into a water stream. The water stream will send the items into an output chest somewhere along the line. In the actual build, there will be one hopper with 9 hoppers on both sides, meaning 19 furnaces funneled into one automatic dropper. Secondly, there must not be a sign in front of the dropper. Then the dropper just spits out the item into an air block, and the items don't move because there's no water to move it around. And furthermore, there should be a second layer of 3 blocks in front of the dropper, because then the dropper might spit out the item too high up and at the system, so this is here to prevent that. In particular, how does this automatic dropper circuit work? Well, when an item first enters this dropper, this comparator will detect this item and then hard power the block in front of it. It will give an output. Then the block will hard power this redstone dust, soft powering this block, and then the repeater will take an output from the soft powered block and output it back into the side of this comparator. Because the signal strength is much greater on the side compared to the back of the comparator, because technically there should only be one item, which gives a much weaker signal strength, this comparator will then switch off. And then obviously the entire thing switches off, the repeater switches off, and then there's nothing going into the side of the comparator, and then because, the item is still in there, it gives another output and repeats a cycle. So basically this comparator will switch on and off repeatedly like a clock. Now why is this important? Well, I still need to mention how it actually powers the dropper. You can see that when this comparator switches on, hard powers this block, which powers the redstone dust, which then will soft power this block, which then quasi-powers the dropper. And a feature of quasi-powered things is it needs to be constantly updated to actually realize it's being powered. That's why this has to sort of cycle around, turn on and off repeatedly to update this dropper to know that it's actually being quasi-powered so it can continually spit out items. Next, I will introduce the output rate for this automatic dropper circuit. In front of me, I have the automatic dropper circuit and a simple repeater clock that is powering another dropper, just for a simple comparison. Anyways, in the explanation, I mentioned that the comparator and repeater have to go through this on-off cycle in order to expel one item out of the dropper. If we count the number of ticks involved in this cycle, so the comparator turns on 1 tick, the repeater turns on 1 tick, the comparator turns off another tick, and the repeater turns off another tick. That means a total of 4 ticks for one item to be ejected from the dropper. Similarly, in this clock, we have 2 repeaters each on 2 ticks of delay, meaning this dropper will also expel one item every 4 ticks. If we test that out really quickly, you can see that both droppers will have the same output rate. Since there are 10 redstone ticks in 1 second, you can convert the output rate of this automatic dropper circuit from 4 ticks for one item ejected to 2.5 items per second. You simply divide 10 divided by 4, which is 2.5. 2.5 items per second is the fastest rate you can get for this specific automatic dropper circuit. And of course this works for other cases as well. For example, if I were to change the settings a bit. Right now I have 1 comparator and a 1 tick repeater. I'll change it to 2 ticks. So now the total number of ticks you need for one cycle, so 1 plus 2 is 3, and then for on-off cycle you need to double that, which is 6. So now you need 6 ticks for one item to be ejected. We'll change that to here real quickly, so 3 on either side, so it's 6 total as well. Just to show the consistency of this theory, you can see that both droppers have the same output rate. Just to summarize this explanation on the output rate for the automatic dropper circuit, I have included a table on screen to show the possible outputs you can get. So you can see there are 3 rows. In the first row is outputs. The highlighted outputs show the possible outputs you can get for this automatic dropper circuit. So for the basic case we have 2.5 items per second. We can also achieve an output rate of 1.66, 1.25, and 1 item per second by changing this repeater. And then for the first row is just Autodropper. You can see what settings you need. So of course it's just a 1 tick repeater and 1 comp or 1 comparator. And the rest are, well, just change this. Obviously 2 ticks, 3 ticks, 4 ticks. And then the last row, Autodrop 2 rep, is just for reference. You don't really need to look at this one, but it just shows this dropper circuit, 2 repeaters, and then 2 ticks for each repeater with a total of 4 ticks. And that's how you read this table. And so, this is where it all comes together. A horizontal line of hoppers has an item transfer rate of 2.5 items per second, which coincidentally lines up with the item transfer rate for this automatic dropper circuit. This means that one automatic dropper circuit is able to support the number of items coming in from one horizontal hopper line. You can see that there is no backlog whatsoever, and the input equals to the output. However, for our case in the Super Smelter, well, this is not the case, because we actually have two horizontal lines of hoppers going into one centralized hopper going into a dropper. This means we have 2.5 items per second times 2, so this centralized hopper will actually receive 5 items every second. And obviously the automatic dropper can't keep up with that, which is also shown here, as the dropper will slowly backlog with items. It is also worth mentioning that a vertical line of hoppers has an item transfer rate of 5 items every second. This is because a hopper is able to pull from above and push down at the same time, so the rate doubles. You can see that there is a backlog forming here because this automatic dropper circuit can't keep up with that. In our case, we do actually have a vertical hopper in the middle, which is here. However, because there is no hopper above to pull down from, this is only able to push down, and it can only achieve half the rates. So from 5, we can only achieve 2.5 items every second, and thus items will backlog in this item hopper. In the larger picture, the hopper item transfer rate doesn't actually matter. Furnaces have a smelting rate of 1 item every 10 seconds, and in our system, we have 19 furnaces that go into one Autodropper. This means every 10 seconds, the system will produce 19 items, which mean that there will be an output rate of 1.9 items every second. As for our Autodropper, this has a rate of 2.5 items every second, and this translates to a maximum processing rate of 25 items every 10 seconds. This means this is able to keep up with the 19 items every 10 seconds that the system produces. Of course, this also means that the maximum number of hoppers we can lead into one dropper is 25. We just have 12 hoppers on either side with 1, so 12 plus 1 plus 12 is 25. And secondly, the limiting factor here is actually the Autodropper, because of the two horizontal hopper lines combined has an output rate of 5 items every second, to show that the speed of the hoppers is always greater than the speed of this automatic dropper circuit. Next, something a bit more simple, just a few numbers you want to pay attention to when you start building the system. This basically translates to some sequences you use to place blocks, which are mostly driven by game mechanics. So, the first one is just a simple water stream, 8 plus 1. This means water can travel 8 blocks for stopping over here, and that's when you need to place an ice block and a sign to sort of like cut that off and then put a new water source block. This doesn't have to be a sign, it could also be a stone pressure plate or even a fence gate. Next we have powered rails, so the sequence here is 8 plus 1 plus 8. So 8 powered rails, and then 1 powered rail with a redstone block above, and then 8 more powered rails. You can see like on the 9th powered rail, this is off because, well, to show that it's out of the range of this powered block, redstone block. Anyways, the last one I have mentioned before, which is the number of hoppers going into one dropper. So for this system, we do have just 9 plus 1 plus 9, so 9 hoppers on both sides going into one hopper going into one dropper, just like that. Now to introduce possibly the most important part of this video, and the reason why I wanted to make it in the first place. This Super Smelter is just a simple balance between input and output. I did mention the output rates for this Autodropper here, and so I'd like to expand on that for a bit more. So I mentioned for the Minecart loading circuit, over here this brain, that the number of items in the hopper will determine the number of items loaded into the minecart. However, obviously because there will be 1 item per furnace, this also equals to the number of furnaces in the system. So that's obviously one connection you can make. So in front of me, I have this list showing all the different possibilities you can have. You have 15 settings corresponding to 15 signal strengths. And so the redstone blocks indicate the more efficient ones. This is the one I used. I put 1 stack and 51 items in my hopper, and so the minecart will load up 2 stacks of items, and this is what Mumbo used. And these are the more efficient ones, because, actually, if you think about it, the more items you need to load up, the longer it takes, and so it will affect the frequency of minecarts. So, how is this considered efficient? Well, if you think about the frequency of minecarts, this is directly translated to the input of items into the system. And so, there has to be an optimum frequency at which we can deposit minecarts in order to maximize the smelting time of items. This is especially relevant if you want to change the size of this furnace. The point that the frequency of minecarts sent out is efficient depends on the furnace. If the frequency of minecarts is too short, that means there are less minecarts and so less items. That means fuel is wasted as it continually burns, and it means that there are periods where the furnace is working, but there are no items inside. If the frequency of minecarts is too high, furnaces can't keep up with the influx of items, so it clogs up the system. Therefore, the frequency of minecarts has to be close to the 10 seconds it takes for a furnace to smelt an item. Just to showcase the frequency of minecarts, here's a table showing my limited amount of testing. This table has two rows to show the number of items in the hopper and the frequency at which these hoppers minecarts are sent out. I've highlighted the more efficient ones, so 1 stack in 51 and 2 stacks in 10, which is here. You can see that these two frequencies, 82 and 92, are very close to the 100 ticks or 10 seconds needed for a furnace to smelt its items. So, how did I reach this conclusion within my table over here? I have just that in front of me. This contraption helps me count the number of ticks between minecarts. So you can see I simply have one of those minecart ejector and storage and then minecart loading circuits here. Then the minecart will get sent out across the rails to one of these two modules, which we'll just go for this one first. The minecart will go over this detector rail and then gets sent into the cactus and it gets destroyed. But that's not the main point here, because when it goes over the detector rail, it activates these two redstone lamps at the same time. That's for the first time. And since this is a piston, this pushes the observer so this can't get reactivated again with another minecart. But anyways, this clock will continually just go back and forth and then reactivate this redstone lamp at a certain interval. Next, when a new minecart comes along and then goes along the detector rail again, this redstone lamp will then reactivate. And so, if these two redstone lamps reactivate at the same time, that means this clock has the exact number of ticks between each minecart. Just to show how this works, we'll be looking at the first module. For this module, there will not be any items in the hopper, and so hopper minecarts will be sent out with a frequency of 32 ticks in between. So there's no items in here, and so let's put some items in the double chest. And then send out the minecart. You can see after a short time that these two redstone lamps will turn on at the exact same time, just like that. And then because this piston ejects this observer, then this clock just continually runs on. Also worth to mention that the number of ticks in this clock are the same as the frequency here. So we just count this, 4 times 4 times 2, 32, which is the same over here. If the clock and the frequency of minecart sent out doesn't match, then the redstone lamps will slowly become out of sync as the tick difference starts to accumulate. So you can see that the subsequent minecarts, deactivate the lamp at the exact same time, so that means the clock is correct. And yeah, just like that. For a better example, here's a furnace connected to the system, so you can see what I mean by item backlogging. This module has the exact same settings as the super smelter I use in my own world, which is just 1 stack and 51 items in the hopper, and so one hopper minecart is sent out every 82 ticks. So just like this. And of course the clock is correct. You can see that all of these repeaters have a delay of 4, except for this one over here. You can just count it yourself. But anyways, since the system sends out one minecart every 82 ticks, this is very close to the 100 ticks needed for a furnace to smelt its one item. And so the furnace, you can see that there's a slight backlog of items that ensures there are items constantly within the system. So basically it means the rate of backlog isn't too serious. It's still able to process each item with sufficient time. And so if I were to switch out a different fuel source, so maybe like coal, which burns 8 items per coal. So it's able to burn consistently without wasting the fuel time because there's items constantly in the system, just like that. Again, really quickly for comparison, we look at the item backlog for this first module. You can see that the rate of backlog is really fast. This furnace can't keep up with that. There's items coming in really quickly, so that's just the difference between the two. What if you have the same number of items in the input chest, but a different amount of items to be loaded into the minecart? In front of me, I have a system to test just that. You can see that this system is just a minecart ejecting system and the item loading circuit, but just mirrored on both sides. And so, in these two hoppers, we have a different number of items, which will load up 1 stack and 4 items, and 2 stacks respectively. This is basically double the amount just for a better comparison. Anyways, here's a chest with items, which I will load into the system. The redstone lamp will turn on just to show that there are items in the chest and in the system. And so we'll test this out at the same time, like this. The first thing to mention is that the system on the left will actually finish. It's quicker than the system on the right. The second thing is a bit of theory. The minecart loading time is comprised of 2 separate periods. The first period is when the chest loads items into the hopper minecart when it's transferring items, and the second period is when it sends off the minecart and calls a new minecart, so this refresh time. And so, from my testing, I know that the send-off time is a lot longer than this item transfer time. This is because the Minecart item transfer time is really quick. It's like 20 items per second, and so it's like shorter. And so, the extra time needed to load up the extra stack of items is nothing compared to the time needed to send out and call a new minecart. And so, for the side loading up one stack, it refreshes its minecart more frequently than the side loading up two stacks. And yes, I know, I missed the lamps turning off. Here's a playback. You can see that the system on the right actually finishes first, though, so it's faster in that regard, because it loads up more items at once. And so the result here is that it's more reason to use the system with more items in the hopper. Now, just a small bit on the different types of fuel you might want to use for your system. You can see I've listed a few types here, complete with the number of items each one will smelt. All four are renewable and of course can be crafted using the crafter. Anyways, if I were to rank which fuel you would most likely use, I'd say that you would use bamboo first, and then coal second, and then kelp blocks third. There are a few considerations behind this. The first is the renewability of fuel, because you need a lot of this sort of fuel. That's why like bamboo can be mass produced, so things like kelp blocks might even be difficult, because it's like 9 kelp for one block, so again, might not be the most optimal. And lava is definitely not one of them, because you can't get 100 like buckets of lava, so no. The next consideration is there are better alternatives to some types of fuel. So there are materials that are made specifically as fuel. So things like wood are not one of them, because wood can be crafted into so many other blocks. So the point I want to bring out here is that different furnace lengths will have different recommended fuels. If the furnace has less than 148 furnaces, or 2 stacks and 10 items in the hopper, less than 2 stacks and 10 items in the hopper, that means I'd recommend a more continuous fuel, because there will be a constant supply of items going into the furnace, so you don't really need to worry about that. So coal works, bamboo works, coal block works, anything works. However, for furnaces more than 148 furnaces, or more than 2 stacks and 10 blocks in the hopper, then you'll receive a non-continuous supply of items. That means it's more like an on-off sort of smelting pattern, and so I definitely recommend using bamboo, because bamboo will be a lot more efficient, as you need 4 for one item, so it can automatically switch off the furnace for that. Next, I will introduce a new circuit to fix something. The current system has an issue that if you put items into the double chest when the minecart is already present on the detector rail, it will fill up with slightly more items than needed, and these items won't get smelted. And the last few items in the double chest aren't sent out because they don't meet the item requirement. And so, in front of me I have a new circuit in blue that will send out the last minecart after a delay without calling in a new minecart. How does this new circuit work? Well, the activating condition here is the number of items in this double chest. You can see there is a comparator here just for that reason. It will detect the number of items in this double chest. Anyways, if you put items into the double chest, this comparator will switch on, which will hard power this block and then deactivate this redstone torch. This piston will then retract, which will bring the observer along with it, and so nothing actually happens. It's only when all the remaining items in the double chest go into the last hopper minecart, that's when there's no items in this chest, and so this comparator will switch off again, so this redstone torch switches on and then extends this piston to allow a pulse to be sent from this observer through these 4 repeaters here and here with a total delay of 16. The last repeater will hard power this block, which will power this redstone dust, to soft power this block, and then deactivate this redstone torch, and then retract this piston to allow the last minecart with all the remaining items to get sent out. I would also like to mention that this circuit, the system, doesn't actually call a new minecart because, well, it's not attached to it. But it doesn't break the existing system because this comparator is still able to do so. This hard powers this block, which will send a pulse through this repeater, and then, well, it goes through. And then because this block is also hard powered, it then powers this redstone dust to soft power this block to deactivate this torch, and then retract and then send the hopper again. So it doesn't break the system. Now the last thing here is just to sort of like sell the circuit. What are the benefits of the circuit? Why do you want to use this? Well, the first thing here is, now you need to press a button to call a minecart and start the system. So it acts like a trap chest. You can like place your items into the double chest, you can change your mind and not smelt, you can like rearrange your items, but now you need to press a button to do so. Next, the first minecart will always get filled with the correct number of items, because it's sent from the back. It doesn't start on this detector rail. And third, if the remaining number of items in the chest doesn't meet the loading requirement in the hopper, it will still get loaded and smelted, plus it doesn't clog up the system. For a counterpoint, here are some benefits for the current system over there. The first is that it's automatic. Since the hopper minecart starts above the detector rail, Items you put into the system will automatically flow into the hopper minecart, and then it gets automatically sent off. There's no need to press any buttons. Secondly, the item will eventually get smelted, even if it's stuck in the hopper minecart or in the minecart storage. It's only when you load in the next batch of items into the double chest will the items get smelted. And finally, here are some advantages and disadvantages for the entire system, not just for one circuit. The first advantage is that the redstone is really simple. If you look at this here, you can see this is basically all the redstone you need. It fits within a really small footprint, and the rest are mostly like mechanical things. So what I mean by that is more like hoppers, furnaces, water streams, powered rails. These aren't really considered circuits, they're just mechanical things. The next advantage is the high variability. You can change the length of this system accordingly, even if it's not efficient. Just change the number of items in the hopper and the number of furnaces. That's it. As for some disadvantages, this super smelter is definitely outdated. This design is from 1.14 after all. There are better alternatives, new mechanics, and from what I've heard, things like chest boats can transfer items into multiple hoppers at once. But the point here I want to bring out is especially due to minecart experiments. Because in a snapshot like a few weeks ago as of this video, they can no longer phase through blocks on slopes. So you can see this exploit I used in the minecart ejecting circuit over here. So that's a thing. And finally, the last disadvantage is that this farm is really late game, so you definitely need like a wood, maybe an iron farm, maybe a gold farm, but you also need some cobblestone, so it is expensive. Turns out I missed something, and it's a circuit as well. This purple circuit is put at the end of the system, so where I put my redstone lamp to show if the system was full, but well, that's been replaced now, with this circuit that sends a signal if the last hopper is full. So if I just were to fill this hopper, you can see this repeater is currently off. I fill this like this, and now there's an output. So what happens? So you can see this is just a really simple comparator thing. This comparator is detecting the number of items in this hopper, and there's a maximum output repeater going to the side. So how do you get a signal from this comparator? You need to match the signal from the side, and so you maximize the signal on the back, so you fill this up, and so that's how you get an output. And there we go. This video is well over 30 minutes. I'm so sorry for whoever is still here, but thank you for watching it. This video is, well, my longest video yet, actually, for some reason. I hope you would learn something and my explanations weren't too hard to understand through the stuttering and such. And so, here's the ending.